Bismillahir Rahmanir Rahim. Our video today is about how our lifestyle choices can seriously affect our biological age and having healthy aging. So I'm going to talk about telomeres, biological aging, and lifestyle factors. As we grow older, our bodies experience numerous transformations, some of which are visible and apparent, like the development of wrinkles in our skin and graying of hair, while others happen on microscopic level. Among the most fascinating cellular changes is the reduction of telomeres, which has been associated with the aging process and illness related to age. Telomeres are repetitive sequences of DNA located at the tips of chromosomes that serve as a protective cap against degradation during cellular replication. As a result, scientists have associated longer telomeres with a greater likelihood of achieving an extended period of good health. During the aging process, our cells undergo multiple rounds of division, and with each division, the telomeres gradually become shorter. Over time, this shortening can result in a condition called cellular senescence, which is characterized by the loss of the cell's capacity to divide and perform their functions correctly. This phenomenon is often referred to as the biological clock because of its close association with aging and the onset of age-related diseases. In this diagram, we can see our DNA with the chromosomes covered by a telomere as a protective cap in its ends, so it will keep the safety and normal functions of our genes in the chromosome. Telomeres are ribonucleocomplexes situated at the terminal ends of chromosomes that safeguard the genome from degradation, unwanted recombination, and changes in gene expression. These are widely recognized as critical factors that contribute to the maintenance of genome integrity. In human somatic cells, the length of the telomeres varies between 5 to 15 kilobase (kb), while in germ cells it's between 10 and 15 kilobase. These structures comprise non-coding areas, TTAGGG repeats, that are enriched, as we see, in guanine, making them susceptible to oxidative damage. Studies have conducted in vitro shown that oxidative stress can hasten the shortening of telomeres and reduce the activity of telomerase, the enzyme responsible for keeping the telomeres in a normal length. A kilobase, abbreviated as Kb, is a unit of measurement used to help for determining the length of DNA or RNA. 1 kilobase is equal to 1,000 of bases. The reduction in telomere length associated with aging has been connected to age-related illnesses like cancer, diabetes, and cardiovascular disease. The shortening of telomeres in general obstructs the functional properties of chromosomal DNA. Telomere length is subject to individual variation and declines during the interval when the enzyme telomerase is inactive after each cell division, eventually leading to replicative senescence. The enzyme telomerase, classified as reverse transcriptase enzyme, attaches telomeric repeats to the three ends of linear chromosome. The elongation of telomeres facilitated by telomerase activity is critical for safeguarding genome stability and preventing the identification and handling of chromosome ends as DNA double-strand breaks. Telomerase is composed of two essential components: a catalytic protein subunit called TERT, T-E-R-T, which have reverse transcriptase activity, and an RNA component known as telomerase RNA component, TERC, T-E-R-C, which contains a template for the production of telomeric DNA. Apart from its two main components, the telomerase incorporates other proteins such as discrins and others that are important for its biogenesis, regulation, and localization. The telomerase cycle for telomere elongation include two primary phases. The first phase is the creation of a single telomere repeat, and the movement of the template. The second is the movement of the template to synthesize additional repeats. However, this cycle can be divided into four distinct stages, including primer binding, elongation, translocation, and dissociation. So, TERT generates a single strand of telomeric DNA that is complementary to TERC, the template, and attaches it to the 3' end of the chromosome. The DNA replication machinery then utilizes the previously formed telomeric DNA strand to synthesize the trailing strand. In this diagram, we can see more clearly the process of how telomerase adds bases to the 3' end of telomere using TERC as a template. So its TERC subunit will be partially attached to telomeric end, while the other part will be attached to or will make a complementary DNA bases that will elongate or repeat this telomere. And then after completing this part of TERC, there will be telomerase translocation to another area, and then will connect partially to this end, and the other part will attract or work as a template for another basis to be attached to telomeric end and make elongation, more elongation of the telomeric end. The maintenance of telomeres, the subcellular localization of telomerase subunits, and the mitochondrial activities are interrelated. Previous studies on aging have shown that oxidative stress and inflammation caused by mitochondrial dysfunction can accelerate telomere shortening in tissue that have undergone the mitotic cycle. That's why individuals who have considerable oxidative damage may experience premature aging conditions and cellular senescence. And as I said before, studies have linked the shortening of telomeres to several age-related diseases, as individuals with shorter telomeres are more prone to developing such conditions. These diseases include cancer, cardiovascular disease, and Alzheimer's disease, indicating that preserving telomere length is essential for healthy aging and disease prevention. Longer telomeres have been associated with longer lifespan and a better health, and also studies have suggested that adopting healthy lifestyle habits can help maintain telomere length and potentially slow down the aging process. Therefore, it may be essential to adopt a healthy lifestyle to promote longevity and overall well-being. So the first lifestyle factor I will start with is exercise. Various studies have suggested that regular physical activity can have a positive impact on telomere maintenance and even lengthening. Aerobic exercises, strength training, and flexibility exercises are all recommended as they can improve overall health and support telomere length. Exercise has been shown to have significant effects on promoting healthy aging and maintaining telomere length. In other words, exercise may be the key to unlocking human longevity. It's essential to find a type of exercise that one enjoys, and this will increase the chances of consistency and long-term dedication, which ultimately lead to greater benefits. The second factor is diet. Diet that is balanced and rich in nutrients play an important role in preserving telomere length. Studies have indicated that diets containing high levels of antioxidants, omega-3 fatty acids, and vitamin D are associated with longer telomeres. A diet consisting of variety of fruits, vegetables, whole grains, lean proteins, and healthy fats is recommended to support telomere health. These foods provide necessary nutrients while limiting the intake of processed foods, refined sugars, and unhealthy fats, which can cause inflammation and oxidative stress, leading to telomere shortening. The third lifestyle factor is stress management. The shortening of telomeres has been linked to chronic stress, emphasizing the importance of stress management in healthy aging. So, having stress reducing techniques such as mindfulness, meditation, yoga, deep breathing exercises, or engaging in hobbies that bring joy and relaxation can help to remove the negative effects of stress on telomeres. So, focusing on self care and having a community support are essential for managing stress and getting general wellness. The third vital component for telomere health is sleep. To maintain telomere length, it's important to have quality sleep, as it allows the body to repair and regenerate cells. Research indicates that lack of sleep and poor sleep quality are linked to shorter telomeres. So, to have healthy aging, individuals should aim to sleep for 7 to 9 hours per night. It's also important to establish a consistent sleep schedule to support the body's circadian rhythm and promote healthy telomeres. Creating a relaxing bedtime routine and optimizing the sleep environment can improve sleep quality. So we have to remember that managing stress and getting adequate sleep are vital for healthy aging and longevity. Other factors that are connected to telomere shortening, and we have to avoid them as much as we can, include smoking, alcohol, and exposure to air pollution. It has become increasingly important to know the mechanisms that contribute to aging and find effective strategies to promote healthy aging, especially with the rising number of elderly individuals around the world. Researchers are investigating the potential of developing therapies to manipulate telomere length as the role of telomeres in aging becomes increasingly evident. Telomerase, which elongates telomeres, is also a significant focus of this research. By stimulating telomerase activity, researchers aim to delay cellular senescence and enhance healthy aging. However, activating telomerase to extend telomeres has potential risks that need to be carefully evaluated. One of the important concerns is an increased risk of cancer, as cancer cells often have high levels of telomerase activity. Therefore, finding a balance between the potential benefits of telomere extension and the associated risks is important for developing safe and effective telomere therapies. Also, there is a growing interest about the possibility of personalized medicine that is targeting an individual's telomere length and other genetic factors. This could be the way for development of targeted therapies and interventions that address each person's specific needs, and so optimizing health outcomes and potentially extending health lifespan. So, making lifestyle interventions and therapies based on individuals' telomere length or genetic predispositions could be beneficial. So, individuals with shorter telomeres or genetic variations affecting telomere length may receive personalized interventions to maintain or extend telomere length, thereby promoting healthy aging outcomes. And as personalized medicine continues to progress, the incorporation of telomere research could have a profound impact on healthcare. This could shift the focus from treating age-related diseases to promoting healthy aging and disease prevention by making interventions and therapies to individual needs based on their telomere length and other genetic factors. I hope that you have enjoyed the video, and before I finish, I want to remind you again to subscribe to the channel and activating the alarming bell so you can be updated with any new video, and thank you.